Here's an example from chapter 3, a word problem. And so let's write down our given information first. We are given the acceleration. It says accelerates at, and you can tell by the units, it's in meters per second squared. So we can write that down right away as acceleration. Okay, we can see we've got a displacement here. So you have a couple choices. You can write that down as delta D. You can also decide that, oops, sorry, that's supposed to be an I. Decide that where the car started is 0 and then where it ended up is 325 meters from there. That's fine. And then there's another given hiding in here. It says starting from rest. That's really important. So that means that it started from an initial velocity of 0 meters per second, that it wasn't moving to begin with. Okay, and then they'd like to know how fast is it going when it's gone this far, meaning how fast is it going later on? So they're asking for VF. Okay, so looking at what we've got, I copied our formulas onto the screen here from the formula sheet. They're kind of small and hard to read, but notice here as we're looking for a formula to use that we don't have time. And we do have distances and velocity initial and A. So we're kind of out on this one because we don't have time. Also because we don't have time, we can't use this one because we've got 2 question marks here. I've got this stuff, but I would have 2 unknowns, so this guy's out. So then this one's looking pretty good. Let's see. Don't know VF, but that's what I'm looking for. VI, I know, and A and delta D, I know. So that's a good equation to use, and that's the one I'm going to choose. So let's copy that one down, and then we will plug into that and solve for VF. And I like to copy the units too, just so that I make sure they all come out right. And I haven't made any mistakes when I copy down the equation. So when I do this, I just get 0 here plus a huge number. This will come out really big. 3. Yeah. I'm going to round as I go to remind myself that I only have 2 sig figs, but you might get a different answer if you keep the number in your calculator. Okay, meters times meters gives me meters squared in the numerator. And then I still have seconds squared down below. And then when I solve, I've got to take square root of both sides. Okay, so I'm going to stick with 2 sig figs because of this 49 here. And I end up having to round to 180. I take the square root of the units also, and meters per second comes out to be a good unit for velocity. That seems really fast, but that's what the book got too, so I'm going to go with that answer. Okay,